So picking up where we left off, we just figured out that 25.5 and 45 were outliers, and we want to create the corresponding box plot for this data set of test scores. So thinking about my scale, I'm going to count by tens. In this case, I'm going to start at 20. The lowest test grade is a 25, and then 30. And then I'll walk my way up to 100 on my scale since 98 was that highest test score. So 90 here and then 100. I already know that 25.5 is an outlier and 45 is an outlier. So I'll put these stars, these asterisks, noting there's an outlier value down here at 25.5 and one at 25. And then for the box plot, the two boxes and the whiskers, I'll start in the middle with my median and work my way out. So on the calculator, remember we found that the median was 81 looking over the left side of my screen. So I'll draw a line here at 81. There's my median, just above 80. And then the left box extends down to your lower whisker, which was your lower quartile, Q1, which was 78. So I'll draw my lower box here. Q1 is 78. And then the upper quartile, Q3, was 89. So just above that 90. So there's my left box, my right box. Then for my whiskers, the right whisker will go up to your maximum value, which in the data set was 98. And then the lower whisker, remember, it goes to the last data value that was not an outlier. So it's not going to go all the way down to 25.5. It gets a star. It's an outlier. It's not going to go all the way down to 45. It's an outlier. The next lowest data piece was 65. That's the lowest piece in the data that is not classified as an outlier. So I can extend my whisker down here just below that 70 in between that 60. So that's what my box plot would look like in this case. So I've got my box plot. And again, it tells me my 25 percentage point breakdown. I can see about 25% of people scored above an 89 on the test. About 25% of students scored below a 78 on the test. And I've got 50% of my class, these two 25 components in between 78 and 89. So that's pretty good results there. So box plots, once again, another way to display numerical data. The final thing to look at with our displays is the pie chart. So pie charts are another way to display categorical data. So we've got the bar graph, which we can make into a Pareto chart if we put the bars in order from the tallest to the shortest for categorical data. But we can also go with a pie chart. It can display categorical, not numerical data. A larger frequency or a larger relative frequency, a larger percentage, means you have a larger slice of the pie. You need to note, however, that pie charts are not commonly used in statistics because it can be difficult to judge the slice of one slice to another. And I've got this article linked here that we'll look at in my web browser. So if we look at this article, just some reasons why we typically don't use pie charts. So here, I've got two pie charts displaying the same data. We're looking at companies and how they compare to one another. And I want to focus on the green slice. So in the top pie chart, you can clearly see you've got a nice right angle here that this company C, the green company, has about 25% of the pie chart here. But in the bottom pie chart, it's the same pie chart, just rotated ever slightly. It's a little bit more difficult to tell that it's exactly 25% just by that slight rotation. So that's one reason we tend to avoid pie charts in statistics. You could throw the percentages around to say, oh, that's 40% with the purple, 25% with the green, and then you could throw the companies, but it just becomes crowded at that point, and you might as well just list out the percentages. Would be just as helpful. Or a bar graph is even easier to see the share of each company. This bar graph would be a Pareto chart. It's the tallest bar down to the shortest bar. It can also be difficult to judge the size of one slice of the pie to another slice of the pie. For example, if I move here, looking at this pie chart, I can clearly see that the orange pie slice is the largest. But then when I have to go to pick the next largest, I've got this dark blue and this sort of medium blue just below the orange. And it's difficult to see and be 100% certain which is the largest. I'm leaning towards the dark blue in the top left and then the medium blue in the bottom. But then after that, it becomes difficult to tell which is larger next from the lightest blue in the top right and this sort of medium orange in the bottom left. You kind of have to think about it. You can't quickly compare which is larger and which is smaller. It would be much easier to gauge if you put it into a bar graph. And so you can see Pinot Grigio is the second most popular with about 17%. Prosecco is second at 16%. And if I look back, Pinot Grigio, that was the dark blue, so that would be the second. And then Prosecco was this medium blue down here, so we were correct. But much easier to see here. And then you can see Cabernet Sauvignon is after Prosecco, and then Chardonnay next. Much easier to see in the bar graph instead of this light blue slice and orange slice. So bar graphs are typically used for our categorical data just because they're easier to read and easier to compare. Pie charts, it can become difficult when your percentages or your frequencies are closer together. All right, so with that, we'll stop here and move into our next topic about the shapes and centers and spreads of our numerical graphs.